Mr. Masa now, and I'm going to be working on sections 1, 2, and 3 for part 1. Okay, so to just start off, we're going to start by defining what a fascicle is. So we see that a fascicle is a bundle of muscle fibers or muscle cells, and a bundle of these fascicles is what make up a muscle, essentially. So if we take a look here at this first image, we see kind of the breakdown of a muscle. We see the tendon with the attachment to the bone, the muscle, one fascicle, and then one of the many muscle fibers that is found within the fascicle. So fascicles could have many different patterns or many different arrangements. So we're going to take a look at the following. The first one is parallel. Parallels are the ones that the length run parallel to the long axis of a muscle. The majority of the muscles in our body are like these. So circular are those fascicles that are arranged in concentric circles, and they surround external body openings. Convergent patterns have a broad origin and converge to a single tendon of insertion. And finally, pennate is broken down into 3 different subtypes, in which unipennate is when it attaches to one side of a tendon, bipennate is when it attaches to both sides of the tendon, and multipennate is when fascicles attach to all sides of the tendon. So if we take a look here, we see a diagram where we see examples of these different arrangements and where they can be found. We see that circular patterns is right here, which is the orbicularis oris. We see the parallel arrangement with the sartorius. We see the convergent with the pectoralis major. And for pennate, we see we see multipennate at the deltoid muscle in the shoulder. We see bipennate with the rectus femoris, and we see unipennate right here on the shin. So when it comes down to how these different muscles, how their shapes yield different actions, it is important to analyze the varying power based upon different fascicle arrangements. Muscle power depends mainly on the amount of muscle fibers that are present. So from weakest to strongest, we go from parallel, convergent, and the strongest is pennate. And when it comes to least to the most shortening ability, it goes pennate, convergent, parallel. Essentially the opposite. And now we're going to be going over part 2 of section 1. So this is all about levers and the leverage system inside the body. So the 4 main components of a leverage system, is the lever, which is a rigid bar that moves a fixed point in terms of the body. That would be the bones. The fulcrum is a fixed point, which in the case of the body, it would be the joints. The effort is the applied force, which would be the muscle contraction that takes place, and the load is the resistance. In the body, that would be the bone, along with the tissue, along with anything else that may be being lifted. Yeah. So now let's take a look at the 3 types of levers. The first class lever, as you can see here, we're going to be looking at examples, are scissors, in which we see that there is effort being applied on one end, the load is on the opposite, and the fulcrum is in between. Another example could be a seesaw. Now, for the second class lever, we see that effort is applied on one end, the fulcrum is on the opposite side, and the load is in between. And finally, the third class lever, this is the most common lever inside of the body. We see that effort is applied in between the load and the fulcrum. It works speedily, however, it is unfortunately always at a mechanical disadvantage. Thank you guys. Hope you guys enjoyed this. Now we're going to focus on the last section, on my part, which is going to focus on muscle actions. Now, let's begin by defining the terms of insertion and origin. Origin is the attachment point that does not move during muscle contraction. On the other side, insertion is the the attachment point that moves during a contraction. Usually, insertion is distal to the origin. That is just something to keep in mind. So now, if we take a look at this image right here, this is clearly an example of flexion, and we see that insertion during muscle contraction moves towards the origin point, which, as we had said, remains stationary. So now, voluntary muscles work across a joint, right? So through tendons, it is attached to bones on both sides of a joint. Muscles move the body by the contraction of the skeleton and the shortening of muscles. So this further causes for the muscles to pull on bones. It is very important to note that muscles do not push, they could only pull bones. Moreover, the position of the muscle as it crosses a joint determines what action or movement will take place. For example, if we look at the shoulder in general, we see that if muscles cross the joint on the anterior side, it produces flexion of the shoulder. If the muscle crosses a joint at the posterior side, it's extension. On the lateral side, it's abduction, and on the medial side is adduction. So, moving on. Muscles must work in groups to accomplish specific actions. For example, the flexion and extension of the elbow is a result of the movement of the biceps and triceps. So, we'll go further into the terms of prime movers and synergists in the next section. So finally, we see that the proper way of learning muscle names is by paying close attention to the relationship between origins, insertions, and the reactions and actions of each muscles. And it's very important to learn these muscle names because the names alone contribute to the crucial information of each muscle, such as location, shape, and movement that can take place. Thank you guys. Hope you guys enjoyed.